Hello everyone. In today's video, we will be discussing network function virtualization, which is often known as NFV. So the today's discussion will be the concept, the architecture, and applications on NFV. Uh, we have been doing a series of videos on advanced networks. Last time we did SDN. We discussed SDN architecture, applications of SDN and various devices used and implemented in SDN architecture. Now today's topic is NFV and we will discuss about the architecture in a little bit short regarding NFV, and then we will continue with the applications of NFV, how we can combine SDN, what are the differences between SDN and NFV. All those topics will be covered in today's video. Now, before moving ahead, have you ever wondered how modern networks handle millions of users without constantly changing hardware? I mean, this is the basic idea behind NFV or SDN. How we can entertain millions of users, because these days the users are increasing in numbers, constantly changing different types of services, constantly using different applications. We have IoT, we have advanced networks, we have software applications, mobile applications. Everything is being used in a in in a huge way. So the question comes is hardware. I mean, till it is a software, it's okay. We can manage on the palm of our hand. But how you will manage the hardware? How how you will resource this sudden increase of the hardware part? So this curious uh, idea brings us to advanced networking technologies. One was SDN, how we tackled the network devices, how we improved the services of the network by giving the whole control to one device, which is SDN controller. Now, what about network function virtualization, NFV? What is the concept? So, if you're a student, a networking professional, or just curious about how today's networks work or how they process all these kind of users, all the services to the users, this series or this video is for you, and I'll try to explain it into a simple and easy way how these things work in behind a scenario or IT word. All right. So let's go ahead and discuss NFV. Uh, NFV is basically a network function virtualization, a paradigm that decouples network functions from proprietary hardware. So here what is happening? Basically, you convert your hardware into a software version. You run everything in the form of softwares. Now, softwares can be ran, can you can run software on your computers, on your laptops, on your servers. So you don't need hardware, you don't need data centers, don't need server rooms. You can control everything with the help of the software. Traditional network functions such as firewalls, routers, and load balancers are replaced by virtual network functions. So, firewall is used for the security, routers for routing the traffic, or load balancers for sharing the traffic. So all these can be managed with the help of software, and this concept is called as virtual network functions. So I hope that you got an idea why network functions uh, virtualization is called network function virtualization. So every part in the hardware is now working as a software. So doing network jobs using software instead of physical machines. Simple idea, key idea. Now, what is the motivation behind NFV? So traditional networks, what they suffer from? They suffer from high hardware cost because you have to buy the hardware for every specific process. If you want firewall, you need to buy a hardware. If you need a traffic routing, you need routers. As the traffic increases, you will keep buying these devices, and this eventually gives you higher cost. Vendor lock-in, you have different vendors, they are not compatible with each other, so you are bound to use a specific vendor-oriented devices. long deployment cycles. It takes a huge time, it takes a lot of efforts to deploy all the configurations on these devices, and poor scalability. So these are the basic issues in traditional networks which can be improved with the help of NFV. How NFV addresses these limitations? Using commodity hardware, enabling rapid service deployment, improving scalability and flexibility, and reducing capex and opex. So we run network functions as a software programs on normal computers. This is what is happening in NFV. Let's talk about another concept known as OpenStack and SDN. What is OpenStack and SDN? So OpenStack is an open source cloud computing platform that manages compute, mm, storage, and networking resources. So basically, it is a cloud platform where you can compute all these things, you can store the information, and you can configure your network resources. OpenStack integrates with the SDN to provide software-defined networking in cloud environments. Now, this part I have brought it here in SDN because OpenStack works together with SDN and network function virtualization also. So I didn't keep this part in the SDN lecture, so it is being brought over here. Key OpenStack components related to SDN. So these are a few components: Nova, Neutron, Cinder, Glance, and Keystone. Nova is used for computing management, and Neutron for networking, which is SDN integrated. Cinder for storage, block storage, Glance for image services, and Keystone for identity management. There are different SDN use case potentials. Now, SDN use case potentials are data centers, cloud computing, 5G networks, IoT, and security. So all these areas implement OpenStack, and they are very new and very useful for today's world. SDN and NFV and OpenStack synergy. So that's the reason why I brought this topic over here. SDN basically controls the traffic, NFV provides virtual services, whereas OpenStack manages cloud's resources. So in tandem, these three work together. So together they enable cloud native networks, network slicing, and service function chaining. Now let's discuss about the network architecture. So basically, now you know the concept. Everything is run by a computer, everything is running on a software. So this network architecture of NFV is based on your network resources, your software resources, and your virtualization concept. So basically, you have three components here, which is NFV management and orchestration, which is also known as MANO. Then you have virtualized network functions, VNF, and NFV infrastructure, NFVI, where you'll find physical computing, physical memory, physical network devices, as well as how you will convert them into a virtualization using virtual layer. So how basically NFV works? Service request is received. NFVO decides required VNFs. So which virtual network functions you will use. VNFs are initiated on NFVI and VNFs are connected logically. Service starts running, VNFs scale or mitigate dynamically. Let's discuss about the components. So NFV follows the ETSI reference architecture, which includes three main components. Virtual network functions. It is basically a software implementation of network functions. You will have virtual firewalls over here, virtual routers, virtual intrusion detection and intrusion prevention systems, then virtual load balancers. So all these are the examples of VNFs, the top component of your NFV architecture. This is known as virtual network functions. Second component is NFV. So we are over here right now. NFVI, so NFV infrastructure provides the execution environment for VNFs. So all these VNFs or all these virtual resources, or you can say processing partners, will be processed here in NFV infrastructure. So this is the environment where these firewalls, routers, or IDS actually processed. So basically what you'll get here, you will get a processor here, CPU is there for computing, then you will also have a storage for storing your information, network resources, and virtualization layer. So it is basically a hypervisor or a container runtime. Third, and a very important component of NFV is management and orchestration, known as MANO. It basically controls the life cycle of VNFs. Components you have NFV orchestrator, NFVO, end-to-end service orchestration, VNF manager, VNFM, lifecycle management of VNFs, virtual infrastructure management, so VIM, resource management. It will have all the resource management. One example is OpenStack, which we discussed in the last slide. So these are the basic, you can say, the components of your NFV architecture. Here, uh, virtual network functions basically works like a worker. So VNFs are the workers. NFVI, that is NFV infrastructure, it is basically the building. So here everything is stored, everything is provided inside this building. The workers are working, and you have the management or the manager in Mano. So NFV management and orchestration is working as a manager who is managing both the components. So you have a building like NFVI, infrastructure is there, and you have the workers, VNFs, and it is managed by Mano. Okay, so this is the major idea behind the NFV architecture. Let's discuss some more components of NFV architecture. So basically you have three components, main three components, but there's few key points which you should know if you are trying to understand NFV architecture. We won't go in depth a lot over here, but we'll discuss important points or key notes which are needed to understand NFV architecture. So basically you have one thing called as OSS and BSS. So some of you might have heard this word. So OSS and BSS is basically operator systems for service management, billing, customer and operations. So very much a component of mobile technology. Interfaces between business layer and NFV Mano. Then you have physical resources. So physical resources underlying hardware and infrastructure, physical computing storage, and network resources. Virtualization layer, basically an abstracts physical hardware, enables multiple VNS to share resources. So this is the layer which will convert your physical part to your software part. NFVI, we already discussed, physical and virtual resources hosting VNFs, includes computers, memory, and networking. VNFs, virtual network functions, it is basically a software implementation of network function. Examples are virtual firewalls, virtual routers, virtual load balancers. EMS, element management system, it basically manages individual VNF operations, fault configuration, performance, and security management. So all the management system comes to element management systems. Then you have VIM, Virtual Infrastructure Management. Basically, it controls NFVI resources, which is infrastructure layer, manages computing, storage, and network virtualization. VNFM, it is a manager, VNF manager, manages lifecycle of VNFs, virtual network functions, and it installs in state scaling, update, and termination. So all the major functions are happening with the help of VNF manager. NFVO is NFV orchestrator, manages end-to-end lifecycle of the network services, coordinates VNFM and VIM. NFV panel, management and orchestration, it is the complete one component, so central framework for managing and orchestrating virtual network services. So this is the major idea behind the architecture of NFV. Now let's discuss about things which connect and disconnect SDN and NFV. So what are the differences? How we can combine SDN with NFV? Now you know SDN is used for traffic control. NFV is used for converting your network part to software part. So they both are different entities, but they can work in tandem with together in specific industries. So we'll discuss about that. That's important part of this lecture. So what are the major differences in between SDN and NFV? So SDN separates control plane from the data plane. NFV basically virtualizes the network functions. How traffic is controlled and forwarded, it is the major part of your SDN. So this is the main focus. Well, while for NFV, the main focus is where network functions run. So he has nothing to do how the traffic will be controlled, how it will be forwarded to the next destination. NFV is basically thinking about where your network functions run. Key concept in SDN, centralized network controller, whereas in NFV, software-based network services. Control mechanism is SDN controller in SDN. Here it is NFV orchestrator, which is the main uh, management area of NFV. Hardware dependency in SDN it is reduced. In NFV it is minimized to zero level. Programmability high, and in NFV it is moderate. Typical examples are traffic engineering and routing for SDN, while for NFV it is firewall, intrusion detection systems, and load balancers. Technology used here in SDN, it is OpenFlow API and APIs, whereas in NFV, virtual machines, containers, these are the main technologies used over here. Main benefit of SDN is network flexibility and automation, whereas the main benefit of NFV is cost reduction and scalability. So they both are advanced topics, they both are progressive ideas, but they are different in and used in different scenarios. How SDN and NFV complement each other. So you know the differences, but they can also be used together in tandem. So how they complement each other. So SDN provides traffic steering, centralized control, dynamic routing, whereas NFV provides virtual network functions, software-based services, on-demand scalability. What they do together? Dynamic service deployment, flexible network management, reduced operational cost, and rapid innovation. So these are the 4 points which is common for both the technologies. They provide you dynamic services. You can easily deploy your services. They are very flexible when we are considering as a network management. They reduce our operational cost and they are rapid innovations. So now we'll discuss about the applications of SDN. In which industry do we use SDN? So SDN is mostly used in data center networking because you have a centralized control of switches, dynamic traffic engineering, and load balancing of large scale data centers. Data centers are on always on a large scale, so you need a dynamic idea or dynamic architecture to bring improvement in the data center networking. Second area where they can be implemented are cloud networking. It gives you virtual network creation, multi-tenant isolation, and elastic network provisioning. Traffic engineering, dynamic path selection, congestion avoidance, and bandwidth optimization. Eventually, it will help you to improve your quality of service. Network automation, zero touch, that means zero touch provisioning, centralization control, centralization configuration, and policy based management. So because it is automated network, you can improvise on all these topics in an easy manner. Network security, you have centralized firewall control, so you basically have one control who is controlling all the rules on the forwarding devices. It can mitigate different types of attacks like DDoS. It has a dynamic access, it has a logical and a top view of the whole network, so it can dynamically access control on all the network devices. Software defined WAN, SD-WAN, intelligent WAN routing, cost efficient inter-branch connectivity. So because it is fast, it is considered to be easy as compared to traditional networks, so it is cost efficient for inter-branch connectivity. Mobile communication networks, very important. network slicing, mobile mobility management, and QoS enforcement, especially in 5G. Quality of service, traffic prioritization, where you want to give priority to the specific traffic, SLA enforcement, and latency management. All these are very important in QoS, quality of service, and SDN helps in improving all these points. Internet of Things, it is today's word. Today's word is running on IoT devices, IoT services. So we need a very and IoT devices usually share a lot of information, lot of network resources are being used. So you need a scalable management of massive IoT traffic and device flows. SDN helps in doing that. Edge computing, a new way of computing. Edge computing, basically traffic steering to edge servers for low latency applications. Again, here also it is improving the flow of traffic because of the architecture, centralized and data plane decoupling architecture helps SDN in improving the traffic flow. So these are some areas where SDN can be implemented, and it is highly recommended to use SDN architecture. Now we'll discuss about network functions applications. So NFV applications. Some applications will be similar, like mobile telecommunication and WAN optimization. Some will be different, like virtual firewalls. We don't use SDN in virtual firewalls. So it is basically a software-based firewall deployment with on-demand scalability. Virtual load balancers, dynamic traffic distribution across servers. So you can virtually distribute your traffic across different servers, eventually decreasing the load on your server. Virtual routers and switches, very much required these days with the need of increasing traffic. Replacement of hardware devices with software-based VNFs. It helps you in reducing the cost also and helps you in managing the routers and switches virtually. Intrusion detection and prevention systems. This is the most important area where most of the research is going on, most of the industries are concentrating in order to avoid or in order to improve the cybersecurity of our networks. So virtualized security monitoring and threat detection, it is one key point which NFV helps in solving to a large extent. Telecom core networks like 4G and 5G. We mostly use 5G these days in most of the places. So virtualized EPC and 5G core functions. Service function chaining, SFCs, traffic passing through ordered virtual services. Edge computing, so it is common between SDN and NFV. We have edge computing usage of SDN also, and here also we implement NFV. So deployment of VNFs close to users for low latency. WAN optimization, virtual WAN acceleration and traffic optimization, enterprise VPN services, software-based VPN deployment and management, cloud network services. So network services offered as on-demand cloud applications. So these are the key areas where NFV can be implemented. If we combine SDN and NFV application, what will be the scenarios? So data center networking, the first application, which is very important these days. So role of SDN, what will be the role of SDN? It will be a centralized traffic control and load balancing. Role of NFV in data center will be virtual firewalls, load balancers, and virtual routers. Key benefit, you will have a scalable and flexible data center operations. Cloud computing. So what role SDN will play? Basically, it will give you virtual network creation and traffic steering. It will improve your traffic flow. Role of NFV will be it will give you services as software instead of hardware, cloud computing. So on-demand services can be given. Key benefits: elastic multi-tenant cloud infrastructure. Service function chaining SFC. So SDN basically directs traffic through ordered services path. So whatever instructions are given by controller, same path will be followed. What role NFV plays? Provides chained virtual services. So here basically you have virtual services. This gives you a benefit of dynamic and programmable service delivery. Network slicing, which is used in 5G. So slice specific traffic steering and isolation. You can isolate the specific traffic. Virtualize slice specific network functions by NFV. So you will have customizable services per use cases. So this is a key benefit in network slicing. Mobile core networks in 5G and 4G. So basically you will get a dynamic routing and session control benefit with the help of SDN, and NFV will give you virtualized EPC 5G core functions. EPC is main component of 5G network architecture in mobile communication. Key benefit: faster service rollout and scalability. Edge computing, traffic steering to edge nodes with the help of SDN, and NFV will give you edge deployed VNFs. So ultra low latency services with the help of both the techniques. Security and DDoS mitigation detects abnormal flows and reroutes the traffic with the help of the SDN. SDN blocks that such traffics also. It can drop these traffic also to mitigate the security issues. What NFV will do? It will deploy security VNFs dynamically. So anything you want to implement or configure on your controller or on your application layer, NFV will be helpful over here. It is very easy to dynamically manage these applications rather than doing a traditional way. Key benefit: rapid threat detection and mitigation. So you can, in no time, you can detect the threat, you can detect the abnormal attacks and mitigate them easily. Software defined WAN, SD-WAN, so intelligent path selection across WAN links according to the SDN, while NFV will give you virtual WAN optimization and security. Key benefit: cost effective and resilient WAN. IoT networks, very important. Centralized flow control of massive services. A lot of research and industry implementation is going on with SDN IoT networks. So it basically gives you centralized control for massive devices. IoT has massive devices, so you have a lot of devices connected to the network. So SDN is very important in IoT networks. Same goes for the NFV. It gives you lightweight VNFs for IoT services. It improves your network resources. It improves the network movement in the IoT networks. So basically, efficient large-scale IoT management is a key benefit if we implement SDN and NFV in IoT networks. Enterprise network automation. So here you will get policy-based traffic control with the help of SDN, whereas NFV will give you on-demand network services. So it is very easy and simple to improve the automation process. So key benefit will be simplified and automated network management. So these are the combined SDN and NFV application scenarios in real world industries. Now specifically we will discuss application of SDN and NFV in data centers and cloud computing architecture. What is the motivation? Why SDN and NFV in data centers and cloud? So basically modern data centers and cloud must support massive scale, multi-tenancy, dynamic workloads, high availability, and rapid provisioning. So these are the key points which you need in data centers or cloud computing. Traditional networks are static, they are hardware centric, they are difficult to scale, complex to manage. So these are some points which brings traditional networks to a lower um, priority when compared to SDN and NFV. So SDN and NFV ticks all the points which are needed for data centers and cloud computing. SDN and NFV transform data centers into programmable software-driven infrastructures. And this is what we need today to improve our data centers and cloud computing architecture. All right. So this table basically gives you application area, again role of SDN, role of NFV, explanation and impact on data centers and cloud computing. So these are some keywords which we have already discussed. So I'll go a little bit faster here. I'll just explain you in a generalized way. So application area is basically centralized network control centralized network control, virtual network creation, traffic engineering, load balancing, network automation, multi-tenant isolation, security services, service function chaining, elastic scaling, and cloud networking. Disaster recovery and fault tolerance and edge computing integration are some other key areas where you implement SDN and NFV when the role of data centers and cloud computing increases. So, what role SDN plays and what role NFV plays in a specific area? So, in centralized network controller, this is the main idea of SDN. So, it gives you centralized control and over switches and the routers. We don't implement NFV in this area. This is totally a part of SDN. Virtual network creation creates isolated networks for tenants, enables multi-tenancy in cloud environments. Traffic engineering, it basically dynamically selects optimal path, the best path, reduces congestion and improves performance. Load balancing, SDN directs the traffic flows intelligently. So there is a control on all the devices, all the network devices, so it can intelligently reroute your traffic. NFE will provide virtual load balancers, so basically it improves application availability and scalability. Network automation automates configuration and policy enforcement, automates service deployment with the help of NFE. Faster provisioning and reduced human error. Multi-tenant isolation enforces traffic separation between tenants because of the SDN, whereas NFV will deploy tenant-specific VNFs. It will secure and isolate your cloud services. Security services steers traffic through security services, provides virtual firewall IDS and IPS because of NFV. An explanation for that will be dynamic and scalable security enforcement because of SDN and NFV. Service function chaining, SDN controls the order of the traffic flow, whereas NFV supplies chain virtual network functions. It's flexible and programmable service delivery. For elastic scaling, SDN adjusts the traffic paths during scaling, whereas NFV provides you VNFs dynamically. In cloud networking, which is also OpenStack component, where here SDN integrates with Neutron for the SDN control, whereas in NFV VNFs run on the cloud infrastructure. So basically, it gives you software-defined cloud network. Disaster recovery and fault tolerance reroutes traffic during failures because of the SDN, because he knows that he knows what is the which route is connected to which path, so he can easily control and reroute the traffic. NFE, it migrates VNFs automatically. Edge computing and integration, here SDN routes the traffic to the edge nodes, whereas NFE will provide or deploy edge based VNFs. Now let's those were the benefits and the application of SDN and NFE in data centers and the cloud. Now we'll discuss application of SDN technologies in mobile communication. So what is the motivation for that? Increasing complexity of 4G and 5G mobile networks every day or with ongoing process, complexity is increasing. Rapid growth of mobile data traffic. Now we use a lot of internet, a lot of information is passing through the internet. We have lots of applications, so there is a rapid growth of data traffic. Need for flexible and programmable networks. So SDN works over here. Supports for diverse 5G services. Efficient mobility and handover management, key component of mobile communication. So handover management becomes more efficient with the help of SDN network. Improves quality of services, centralized control and simplified network management, faster services deployment and reconfiguration. You can easily reconfigure your devices because of the SDN. Reduced operational and capital cost, enhanced security and real-time threat mitigation. Again, it improves the security because of the SDN. Seamless integration with the cloud, NFV and edge computing, and future-ready architecture for 5G evolution and beyond. So SDN enables flexible, scalable, and programmable mobile networks to meet modern 5G service demands. Some key areas, application areas of SDN function. So core network control is the main idea behind the new mobile technology. So SDN basically gives you centralized control of mobile core. Network slicing, slice specific traffic steering. So it is used for traffic steering. Mobility management, you need a control and management over the mobile networks. So dynamic update of forwarding paths ensures seamless handover and session continuity. Traffic engineering optimizes routing across backhaul and cores. So it improves bandwidth utilization and reduces latency. Quality of service, policy-based traffic prioritization, with the help of SDN. It guarantees service quality for diverse applications. RAN optimization, key component in mobile architecture, radio access network. So centralized control of RAN resources with the help of SDN improves spectrum efficiency and load balancing. Cloud RAN, which is RAN, so your radio access network is cloud based. Here again, centralized control of basebands units reduces operational costs and improves performance. Security management, centralized monitoring and mitigation, so you can easily control your traffic which is coming to your network devices, and you can mitigate any kind of threat. So rapid response to threats such as DDoS attacks. Edge computing is major area of mobile networks, so traffic steering to edge servers enable ultra low latency services. Backhaul optimization, dynamic control or transport links, policy enforcement, network-wide policy control, and 5G core integration is again one area where SDN can be helpful. It supports service-based architecture, enabling flexible and scalable 5G deployments. So this brings an end to a series of lecture related to SDN and NFV. There will be another video where I will try to show you the implementation of SDN using some software, probably Mininet, and try to install controllers, RU and like RU or ONUS, and then we can show you how the traffic can be moved in SDN. So for that we'll have another lecture, but this lecture ends over here. To summarize all together, SDN, software-defined networking, introduces centralized and programmable control of network traffic, enabling flexibility and automation. So basically, you have a centralized control on all the forwarding devices, whereas network function virtualization virtualizes. So there is no central control. It is just virtualizing the whole network service into a software-based system, so allowing them to run as a software on standard hardware. Together, SDN and NFV support scalable, cost-efficient, and dynamic network architecture. So these are the most advanced architectures these days, specifically needed for data centers, clouds, and mobile telecommunication industry. So SDN and NFV collectively form the foundation of future and intelligent and software-driven communication systems. We'll bring more of SDN and NFV topics in this series. We'll bring the practical implementation of SDN soon in our channel, so you can stay connected. I hope things are clear for you. Today's lecture was more about application in data centers, cloud, and mobile technologies. Thank you for watching the video, and have a very good day.